Hello and welcome to today's lesson on the use of colour filters. In today's lesson, we'll begin by developing our understanding of how colour filters work. We'll then discuss real-world uses of colour filters. So far, we have learnt how each colour in the visible spectrum is associated with different wavelength ranges and classified objects as transparent, translucent, or opaque. We also discussed how colours of opaque objects arise. Building on this foundation, we can now understand the function and application of colour filters in manipulating light. Colour filters function by absorbing certain wavelengths of light while allowing others to pass through. When light encounters a colour filter, only the wavelengths that the filter allows will pass through. The rest will be absorbed. This fundamental principle of filters is essential in many applications, from photography to lighting and even in enhancing vision. When light passes through a colour filter, the light that comes out is often a different colour than what went in. This is because the filter is selectively permitting only specific wavelengths to pass through. For example, let's consider white light, which contains all the colours in the visible spectrum. When white light passes through a red filter, only the red wavelengths are transmitted and all other colours are absorbed by the filter. As a result, the transmitted light appears red. Similarly, if white light passes through a green filter, only green wavelengths are allowed to pass, making the transmitted light appear green. Viewing objects through colour filters can alter their appearance based on the colour of the filter used. This happens because the light reflected from the object interacts with the filter. For instance, if you view a blue book through a blue filter, the appearance remains unchanged because the blue wavelengths reflected by the book pass through the filter. However, if you view a red apple through a blue filter, the apple appears black. Why? Because the blue filter absorbs most of the red wavelengths that the apple reflects, thus very little to no light passes through. Hence, the apple looks black in colour. Colour filters have various practical applications across different fields. For example, filters are used to manipulate and enhance colours in photographs. For instance, landscape photographers might use a polarizing filter to reduce glare from water surfaces or to enhance the contrast between the sky and clouds. In stage productions and film, colour filters are used to create specific lighting effects that can alter the mood and ambience of a scene. For example, a red filter might be used to create a warm or intense atmosphere, while a blue filter could create a cooler, calmer setting. Finally, sunglasses often use tinted lenses to reduce glare and improve contrast by filtering certain wavelengths of light. This can make it easier to see in bright conditions and reduce eye strain. These examples highlight how the principles of colour filtering are applied to enhance visual experiences in various contexts. In today's lesson, we delved into the use of colour filters within the visible light spectrum. We learned that colour filters function by absorbing certain wavelengths of light while allowing others to pass through. This process changes the colour of light after it passes through the filter. We demonstrated this by observing how white light changes colour when it passes through different filters. Additionally, we explored how objects appear when viewed through colour filters, discovering that the apparent colour of an object can change based on the filter used. Finally, we discussed practical applications of colour filters in various fields such as photography, in lighting, and in vision enhancement. This lesson has provided a comprehensive understanding of how colour filters manipulate light and their practical uses in everyday life. Watch the rest of the GCSE Physics course at Sophos Education.